Hello, I am Mr. Singleton, and this is the Forces Year 8 lesson. And we are carrying on from the last week when we've just talked about terminal velocity and unbalanced forces in Newton's law. So, a pre starter. Now, if you are at school, you can do this onto a whiteboard on your planner. If you're at home, then you can do this on a piece of paper. And all you really need to do is just draw three boxes on the left hand side, three boxes on the right hand side, and join up which way you think each box goes. So you don't need to be writing out all those words at this point in time. So we have lots of different variables when we are doing experiments and practicals, and you need to know what those variables are, either because you want to be a budding scientist or because you want to do well in your GCSEs. So I want you to tell me what an independent variable is. The definition is on the right hand side there. The dependent variable is, and what control variables are. So you just need to draw lines to match those up. I will give you 2 minutes. Off you go. Okay, you got 30 more seconds. All right, let's go through these then. So the independent variable is the thing that you change. Now, if you think about the word change, it begins with a CH, and independent, IN, then I always remember chin. So change is the independent variable. Or you can remember inch if you remember, if you know that one. In, IN, and then for change. So inch for independent is the one that you change. Dependent variable is the thing that you measure, and then the control variables are the things that you need to keep the same in the experiment. This is just going to link into this experiment that we're going to do today. We are going to investigate terminal velocity. So the title is Investigating Terminal Velocity. You need it written down in your books or on your paper if you're at home and underlined. Off you go with today's date. Oh, let's get on with today's lesson. The challenge is to be able to plan a method and to record results. I'm going to do this by videoing the practical and you recording the results, but you need to be able to plan this as well. And then what we're going to do after that is we're going to try and calculate a mean and plot a graph from our results. So, starter, how do you find the mean of a group of numbers? So, just a written description on how you do that. And then I want you to work out the mean of those lengths of pencils. I will give you 4 minutes because you might need need to get a calculator, and there's a little bit of writing there. 4 minutes, off you go. Okay, you've got 30 more seconds. Right, let's go through some answers. So, how do you find the mean of a group of numbers? What you do is you add all the numbers together and then divide by how many numbers are there. So on this side, over on the pencils, you would add 6.5 to 6.6, add 7, add 8, add 6.8, and add 6.7. Okay, and then you would divide it by how many there is. So there is 6 there, so you divide it by 6. So the answer is 6.9333 recurring. Now, two things about this. There are some issues with that mean. One is that if you put 6.933333 Well, your decimal point, you're only on one decimal point in that table, so it should be to one decimal place. So it should be 6.9. The other thing is you can see that one of those is an outlier. So one of them does not fit the pattern. Have a quick think about which one do you think does not fit the pattern. And hopefully you've gone for 8. 8 is a lot more different than the other numbers there. So that would be an outlier. So you wouldn't necessarily include that in your mean. So what you should do instead is you should do the 6.5, the 6.6, the 7, the 6.8, and the 6.7 again, and only divide that by 5, and then you get 6.72, which is a lot closer to the average number that's there. Okay, so that's what was wrong with the. So we're going to do an investigation on the terminal velocity of bun cases. These are them things that, them little cupcakes come in. So I want you to have a think about how you could investigate the terminal velocity. So if I'm dropping them bun cases, what equipment would I need? So this is writing a plan. What equipment would I need? And then how would I do the investigation? I'll give you two minutes just to have a think about it, and then we'll go through it. You've got 30 more seconds. So to investigate the terminal velocity of these bun cases, what you would do is you would need to get your equipment, which is 5 bun cases, a meter ruler or two 1 meter rulers, a stopwatch. Then what you do is you measure 1.5 meters from the ground, and then you drop your bun cases from 1.5 meters and record it. Then you repeat that at the same height with the same bun case another 2 times, and then you're going to repeat all them steps with 2 bun cases and 3 bun cases and 4 bun cases and 5 bun cases. Now I want you to have a thing. Before scientists do experiments, they have to carry out a risk assessment, and that's to look at what are the hazards, what could be dangerous, what could go wrong because of that hazard, and then how you control it to reduce the hazard or the risk. So I want you to think about this. I'm going to be dropping bun cases from a height of 1.5 meters. What's my risks? What are my hazards? And how can I control that? So you need to draw that table onto your paper or into your books, and then think of some risks. If you've got somebody next to you to talk to, then please do talk to them about it. I'm going to give you 2 minutes. Off you go. Okay, so some of the hazards, you might need to be stand on the stools, so someone could fall off. So you make sure that you are just standing. That's why we've used 1.5 meters instead of 2 meters. Meter rulers, you might hit somebody, so you just need to be careful that the meter ruler's in front of you, and then just put on the bench when you are not using them.
Before we start this experiment, I just want to talk to you about table of results. If you can get this right now, it's just going to benefit you for the rest of your science career. Now, when you are looking at this table, you've just got to think, what is my independent variable? Remember that starter we did? Well, that's why we did it. The independent variable is the thing that's going to go in the first column for your table. So in this case, my independent variable, the thing I'm going to change is the number of bun cases, and that is what goes in that first column. Then I need to think about what is the dependent variable. Remember, that's the thing you are going to measure. Well, that goes in the right-hand column. Now I'm going to repeat this experiment 3 times and then pick a mean up. So that's why I'm going to put time in seconds for test 1 and test 2, and time in seconds for test 3, and then work out the mean like we did for the starter as well. So that is how you would draw a table every single time. In the left-hand side column, the thing you're going to change, or your independent variable. In the right-hand side column, the dependent variable. Here are some results. So what I want you to do is copy down this table into your books or onto your paper, and then try and work out the mean. Now what you need to look closely is there any anomalies in that table? And then remember, you don't include those anomalies in your mean. I will give you 3 minutes to draw that table. Remember, if you are struggling to do that in 3 minutes, then pause the video and make sure you take your time and draw this nice and neatly with a ruler. Okay, you've got 3 minutes, off you go. Okay, you've got 1 more minute left. Right, Brill, if you need to, then please pause it. I'm going to move on to the next slide.
So now you have some of your results, you should be able to draw a graph, okay? So it's a graph of the mean time. Make sure you worked out the mean by adding those three together and then dividing them by 3, and then the number of bun cases. Now remember, on a graph, the thing that you changed, which in this case was the number of bun cases, that is the independent variable, because that's what we changed. And that will go along the bottom on the x-axis, as it's called in maths. The y-axis is the thing that you measured. Remember, that's called the dependent variable. So that will go on the y-axis, and that was the mean time. So we were measuring the time it took to fall. So, and then it's just a little cross for each one. So there should be 5 points. And then you need to label your axes, and make sure you've got units of your axes, plot your points, and then draw a line of best fit. So those are the things that you need to have done. I'm going to give you 5 minutes to draw your graph. Okay, so you've got 1 more minute, but if you still need more time, just pause the video. Okay, so make sure you have got your axes labelled and plotted your line of best fit. Make sure you've got sensible scales. Make sure you've labelled your axes and you've added units and plotted all your points properly with a line of. This is now into lesson 2 for this week's lessons. So I just want you to have a think about this. Which weighs more, which also had greater mass, a kilogram of gold or a kilogram of feathers? And then which one would have the greatest volume, a kilogram of gold or a kilogram of feathers? I'll give you 30 seconds to think about it. Off you go. So hopefully you have worked out that a kilogram of gold and a kilogram of feathers are the same mass, so therefore they both have the same mass. So neither of them weigh more, as we put it. And then which one has the greatest volume, a kilogram of gold or a kilogram of feathers? Well, you would need a whole lot of feathers to get to a kilogram, so they would have the greatest volume. So this is into this lesson today, which is about density. So we've done all of these other lessons previous to this. This is a little bit separate, but it's about density, so it's still about forces. So our title today is density. Make sure you've got this written in your books and underlined with today's date. If you are at home, on a piece of paper, underline the word density. Okay, so what we are going to try to do is calculate the density of a regular object, and then our aspire is to be able to calculate the density of an irregular object. So first thing I just want you to think about is how would you actually measure the mass of an object, and then how can you measure the volume of an object? So let's have a look at that gold bar there. How would you measure its mass and how would you measure its volume? So to measure the mass of an object, you can just put it onto some scales or a top pan balance, and that would give you its mass. The volume is a little bit harder. You'd have to measure its length, and then its height, and then its depth, and you times all those together, and you will come up with the volume of the object. To work out the density, and density is a measure of how much mass there is in 1 meter cubed of a substance. So it's how tightly packed all those particles are. It tells us how dense it is, and in terms of the actual density units, it's how much mass there is per 1 meter cubed of a substance. And it's calculated by this equation. Now in the GCSEs, you have to remember this equation. So it's density equals mass divided by volume. Now, if you are ever given the units for density, which is kilograms / meters, which means per meters cubed, that will help you with remembering the equation. If you can remember that kilograms is measured in mass, or as a unit for mass, and then meters cubed is the unit for volume. You know, if you think about your drinks cans are about 33 centimeters cubed, then you can remember the equation because that slash just means divide. So it's kilograms, which is mass, divided by volume, which is meters cubed. All right, it just gives you a helpful hint. So that's how you work out the density of an object. So which one of these, just thinking about which one would have the highest density. If you had 1 meter cubed, which one would have the highest mass if you had 1 meter cubed of it? So is it the pillows, the water, the empty cardboard box, some books, some marshmallows, or some they look like cast iron weights or dumbbells? "30 seconds. Okay, so hopefully you would say that the dumbbells at the bottom would have the highest mass if you had a meter cubed of them in terms of its volume. If I wanted to measure the density of a regular shape, then it's quite easy. And by regular shape, I mean the one that has a normal a shape to it. So it's like a cuboid or a cube or a cylinder or something like that. Something I can find out the volume with very easily using general formulas that we have in maths. So all I would need to do is find the mass of the shape and record its mass using a balance. And then I would measure the height, the width, and the length of the object, and I times them together. And then I can find its density by dividing the mass by the volume, and then make sure you include your units. So it's nice and easy for a density of a regular shape. That is all you need to do, but I will show you a video of it on the next slide. From earlier on in the lesson, density is the mass divided by the volume. So the first thing I'm going to do is try to find the mass of this and then the volume of this. This is a regular shape, all right, so all I have to do to find out the volume of this is use my ruler, okay, and size it up. So the length is 5, the depth is 2, and the width is 2. So to work out the volume of my regular object, I'll do 5 times 2 times by 2, which gives me 20 centimeters cubed. Next part's really easy. I've got my volume. Now I'm going to find my mass, place it onto the top pan balance, and now I can start to plug in my numbers. So density equals the mass, which is 169.05 divided by 20. So I'm going to put that into my calculator. Please remember to use your calculator in your exam. So then the density is 8.4525 grams per centimetre cubed. And then they might ask if you wanted to put that into, let's say, 3 significant figures. You would go 8, that's one of my significant figures, 4 is my next significant figures, and then 5 is my next one. And because that is lower than 5, then it can stay at 5. So that is how you work out the density of a regular object. What's a little bit more difficult is if you've got the density of an irregular shape. So these are the ones which don't necessarily have the normal shape of like a cylinder or a cube or a cuboid. So it's really hard to find its volume. Now the same thing is I would find its mass by putting it onto a top hand balance. But the next bit is a little bit harder. So there are these things called Eureka cans, and these are just little cans, cylinders, which have a little spout on them. And what you do is you fill the water up to just below that spout. And then when you place the object into that spout, the water is displaced, so it rises up. And the amount of water that comes out of that spout then is the volume of that object that was in there. So you put a measuring cylinder under that spout, you can catch the water that comes out, and then you've got its volume. And then again, you divide the mass by the volume. I will show you again this experiment so you can see it properly on the next slide. So we've done regular shape objects, now we're going to do irregular shapes. So I can't get this volume by just timesing this bit by this bit by this bit. All right, I'm going to have to find the volume a different way. All right, and the same can be said for this piece of stone here. It's not a regular shape. So what I can do is I can work out the volume by how much it displaces. So if you look at this here, when I put the object in, the volume will go up. Now the amount that volume goes up is the volume of this object. Pause it there. So a student wants to calculate the density of these two objects. Describe the methods the student should use to find the density of these two objects. So you've got a metal cube, okay, and then you've got a small statue. One of them is obviously a regular shape, the cube, and the statue is in irregular shape. So I want you to write down the two methods which I've just shown you for the metal cube and the small statue. I'm going to give you 5 minutes. It's quite a bit of an extended writing task. Off you go. Okay, you've got 1 more minute left. Thirty more seconds. Okay, if you are still writing, then just pause your video, and then we can, and then you can carry on writing and finish. If not, we'll go through. This is the mark scheme. Really useful to keep having a look at these kinds of things because it gets you into exam practice on what the marker is wanting. Both of these situations, so for the small cube and for the small statue, then you have to find the mass using a balance, and then both of them you need to say that you would use the equation density equals mass divided by volume. That little P looking like symbol is actually rho, so it's like a diagonal P. It's just another letter used to show density. Really important that you remember to use the equations. Whenever you're asked for your method, and if it uses an equation, please put the equations in. You will always pick up a mark for that. For the metal cube, nice and easy one. All you have to do is measure the length. You could say measure the length, the width, and the height of it, but because the cube, they'll all be the same size. Times them together and then calculate its volume. For the small statue, though, you should use a Eureka can, place it into the water, and measure the amount of water that comes out of that Eureka can, and that will tell you the volume of the statue. Okay, so make sure you mark that up. It was a GCSE question, so if you're doing well with that, you're doing amazing. Last bit of this lesson, I want you to try to recall the equation for density and what units can be used for density. So what are the units and how do you find or what is the equation for density? I'll give you 1 minute to write those down super quick. So what we should have for the density is density equals mass divided by volume, and the units for density is kilograms per meters cubed. That is the end of this lesson. We are going to move on to the next lesson. So this is lesson 3 in this section of this week's work on forces. So we have just finished looking at density. We are now moving on to the next lesson. What I want you to do is think about which one of these materials can float in water. Okay, so just list them on your whiteboard or on your paper at home, which one will float on water. Off you go. Okay, so we should have the plastic bottle, the twig in the top middle, and then the corks at the bottom. So we're going to look at something called upthrust today. So we did about density, now we're going to look at upthrust. So your title is upthrust. That needs to be in your books if you are in the classroom, or if you are at home, then just a title on a piece of paper, up thrust. Off you go. So what we are going to do today is we are going to record some observations and then analyse some results. But then the aspire here is to explain why materials float and then why some materials won't float. To find out if an object will float or not, we need to know two things. We need to know the density of water. Now, the density of water is pretty similar everywhere, unless it has other materials in it, which we will look at in a second. But generally, the density of water is 1 gram per centimetre cubed. If a substance has a higher density than water, so it is more dense, then that object will sink. But if a substance has a lower density than water, then that object will float. And that is one way to find out if objects will float. If you look at these two situations on the side, so we've got a force meter and it's attached to a hook, and you have the pull of gravity when it's not submerged in water. However, when you put that object into water, then actually it gets some pressure which causes an upward force. So it pushes it upwards when it's partially submerged in that liquid. And that upward force is called up thrust. Okay, so it's a pushing up force that occurs in water, and it's because that bottom surface has a higher pressure on it. This is a real world situation. So this is a special sea actually, which is found on Earth, which allows people to actually float in the water. So I want you to tell me, what are the forces acting on this person? And remember from previous lessons, there will be two forces acting on this person, and they act in equal but opposite forces. And then are the sizes of them forces the same, or is one bigger than the other? 30 seconds, have a think about it, off you go. Okay, so actually this person is floating in the Dead Sea, and that actually, the sea contains a whole lot more salt than other seas. And what that does is it makes the water a lot denser, and so it displaces weight more. So then there is a larger up thrust. So you should have had weight and up thrust are the forces which are acting on her. And actually, because she's staying in one place, the forces are equal. But the upward force in this case now is called up thrust.
Another use for this is these things which are airships, and these are filled with a gas, and obviously it helps them to float up above the land, and you move people around and things like that. They're not used as much anymore, basically because one of them exploded. But on the next slide, it just shows you how they work. Here are two situations that you would have with this airship. One where it needs to go up, and the other one where it needs to come back down to the land. I want you to have a look at these three questions and try and work out the answers. This is a bit of stretching and challenge for you. Question 1 is, what is the purpose of the helium gas, which isn't too hard. But then why does the airship go up when air is forced out of the bayonets? balloonets, and then why does the airship go down when they suck air into it? I'm going to give you 2 minutes to have a discussion if you are in school, or just to gather your thoughts if you are at home, and we'll see if you can come up with the right answers. 2 minutes starting now. So the purpose of the helium gas is obviously to make it less dense than air, and that then allows it to go up. That's why balloons filled with helium will float. However, if you look at balloons which are filled with air, the ones that you breathe into, they don't necessarily float because there's that rubber around them which makes them more dense than the air and brings it down. Why does the airship go up? When the air is forced out of the balloonets. When the air is forced out, then the whole balloon has less density than the air around it, so therefore then upthrust will be more than weight, so therefore it will move up. Why does the airship go down when air is sucked in? That makes it more dense than the air around it, which means the weight also increases, and therefore then the weight is more than the upthrust, which then makes it come down. If you got them, you're doing a fantastic job and well done. The very last bit of this lesson, just trying to put all of this together. How do you know from this picture that the density of oil is less dense than water? I want you to have a quick 20-second think or a scribble on your paper to give me an answer and see if it's the same as mine. You're going to have to use the word density, and you're going to have to compare that to the density of oil and the density of water. 20 seconds, quick write down, off you go. Okay, so hopefully you've put that because the oil is floating on top of the water, it must be less dense than water. Brilliant job. That comes to the end of these density and forces lessons. You've done an amazing job. Well done.